doesn't take any of my cables. Okay, no problem, no problem. Okay, ladies and gents, last but not the least, our final lecture on day one here on track A. Let's see the video. Marco Pivetta. And now our friend Marco, after yesterday's workshop, we will talk now about event sourcing, the good, the bad, and the complicated. Sounds nice, right?
Sorry?
Sounds nice, right?
It sounds nice, yes.
Can we have an applause for Marco?
Louder! Thank you. Okay.
Okay, Marco, enjoy your time. See you after you finish. Thank you.
So should we just start here? What do you think? Yes? All right. Computers. Right. Does this work? This doesn't work. Okay. Right. So, hello. Nice to be here again. This is kind of a surprise because yesterday I was talking to Nicola here, and we were like, yeah, Marcus, so how's your talk tomorrow? And I was like, a talk tomorrow? What? And yeah, then we had like a minute of looking at each other awkwardly. Right. This isn't working. Right, I'll have to stay here. So, I'm Marco. Is it working? Yeah? No? Yes? Software. Right, I'm Kramius on the internet. I'm one of the guys behind the Doctrine project, one of the folks behind Doctrine project. I'm helping with the framework, and I work for a company called Rove. We're consultants. I like the definition of consultant given by Uncle Bob Martin. A consultant is like a seagull. So they come over to your place, they eat all the food, they do a lot of noise, they shit all over the place, and then they leave. And by the way, with all the money, we just go to conferences. Today we're talking about event sourcing. Event sourcing, the good, the bad, and the complicated. So what I want to ask here is, who here has experience with event sourcing? 1, 2, 3, maybe 10 people. Right, this is quite normal. I wouldn't say new stuff, because every mature industry kind of uses this, but our industry is everything but mature. To introduce it, I want to make a couple concepts clear. To make these concepts clear, I need an example project. So I have a software project. This is not a product pitch, by the way, because it's not live anyway. It's called codereviews.io. And the idea is relatively simple. It's to make money, first of all. The problem is this. People need to get code reviewed. They have no expertise in a certain topic. So they come to us, and they pretty much ask us to do the reviews. Okay, so first of all, in a software project, if you're writing a new software project, you should have one of these two aims. Either you're helping your users, if you're a non-profit, or you're helping yourself by making money. Otherwise, don't write a software project. I have way too many open source projects, and it's not worth it. It doesn't pay off, okay? It's just sleepless nights. So when you have a software project, if you're going somewhere, it better be at the end of the rainbow with the pot full of money. So what happens is that somebody sends us some code, okay? First of all, they send us some code. Then we evaluate how much it will cost to review it. Is it going to be $100? Is it going to be $200? Whatever. Then they pay us. Give us your credit card. We're going to save it, obviously. Don't save credit cards. Very, very bad idea. It's going to cost you a lot of money. And then the review gets listed on the marketplace. So once you paid, once you provided payment for it, we can actually show it outside and say, okay, people, show up, come here, help us review. Somebody will apply, like as an auction, I want to do this, I want to do this. People that say, I'm experienced with PHP, with Scala, with Java, whatever. And suddenly, at the end, work happens. So one person is picked, work happens, the review happens, and once the review is completed, people get paid. The problem here is that we have a set of interactions that happen in a very precise sequence, one after the other. This happens in a lot of software projects. You can think of a simple e-commerce as the base, where you have a shopping cart. First you create a shopping cart, then you add products, then you check out. All right? That is one of the things that is happening in this kind of system. You have chronological order of interactions. And you have processes. So one interaction depends on the previous one. The input of one depends on the output of the previous one. What can happen is that there are a lot of scenarios where people can say, no, I don't like what is happening. So you have variations in this workflow. Like, exactly like in a factory, you find the bad apples and you want to throw them away. Same here. You want to have a process for dealing with everything that is not what we developers call the happy path. The happy path is where everything goes nice and shiny, and the unhappy path is where we spend most of our time developing, debugging, and so on. So people can be unhappy about how much they have to pay. People can be unhappy with the work being done, with the list of applicants, like 500 bots subscribed and said, yeah, I want to do the job, and it's just bots all the way down. By the way, there was a talk about chatbots. I don't like bots overall. They're a bad idea, in my opinion. They can be unhappy with the work being done, so somebody started doing the review and then you only got coding-style comments. That's not a review. Please don't do coding-style comments on code reviews. If there are some problems, yes, but you should first focus on the other stuff. And the other thing that happens is that you have external systems. You are talking with payment processors. You are talking with mailing systems. We are talking with Git. You know how easy it is to screw up in Git, to introduce problems. So you have these kind of problems. You have GitHub. GitHub has this traditional offline time once a month, where you have to have either a coffee break or you call it a day. It happens, right? They're still much better at ops than any of us. Imagine how much it must be, what kind of load you must be on their side, having pretty much all of the software world depending on them. That must be quite a lot of work. Then you have tools like Fabricator. You have a tool that you are using, you're deploying it, but it has its own requirements, its own failures. You didn't develop it yourself, so if it fails, it fails. You cannot really debug it and fix the problem. You have to rely on the fact that failures exist and they will be inevitable. You can have Bitbucket, GitLab. Anybody using Bitbucket and not died of old age already, right, while waiting for a page to load? GitLab is not better anyway. You have Stripe. So far, I didn't have any problem with Stripe. But if this fails, this is where the money disappears. We don't want to have that. And then you have other things like notifications. If you know about Mailgun, they probably had a fun day yesterday. Did everyone survive GDPR day? Yes? Right? Just fill out the form and send me your email address so I can send you advertisement about this talk later. So effectively, this doesn't look good. This isn't easy. This is a lot of problems. So if you were to take on this journey alone, it would probably not be a good idea. But what happens is that I started looking at a lot of patterns that were quite interesting for developing process-oriented applications around 4 years ago. and I started writing libraries in an organization called github.com/shittysoft. My dream is that at some point I will release a library that is widely used, right? And it's under the Shittysoft namespace, and then somebody in production will have Shittysoft in their stack trace, publicly visible. That will be amazing. So effectively, this doesn't look good, but if you follow the right patterns, you can get somewhere. And these patterns that helped me were effectively CQRS and event sourcing. So let's go back a second to what traditional applications do. Traditional applications generally are what we name CRUD-alike applications. So in a CRUD-alike application, we have something like the initiation of a transaction, right? Starting a transaction, which means effectively connecting to the database, opening a database transaction, which is already quite a jump. You have to connect to an external system. You are connecting to a database, starting a transaction, then you execute some business logic. I don't know what these guys are doing, but the idea is that you call some service, and some things happen. What then happens is that inside, somewhere, in what we are currently doing, there's an ORM or something like that that computes the changes. You don't know what is going on. You probably don't want to look in there. If you're using Doctrine, I'm sorry. All right, don't worry. Everything is going to be fine when you migrate away from it. And then the Doctrine, or the ORM, is supposed to throw the database changes, the changes at your database. So everything that changed got thrown at the database. You got the final state of the application. Yes. And this is pretty much what we are dealing with in any kind of complicated application. In a complicated, complex, I would say, application, not complicated. In a complex application, we have scenarios that we need to inspect. Why is this kind of order not valid? Why is this kind of order not shipped? Right? We need to do this investigation of the crime scene. We are both the investigator and the murderer at the same time. So what I like is that by moving to event sourcing, we're changing the kind of idea behind this development completely. So in event sourcing, which is quite a new thing, so I don't expect a lot of people to kind of like be, oh yes, this guy, okay, I know everything he's talking about. In event sourcing, we are saving history, points in history, things that happened in the past. So in the previous example, you would have the fact that the people entered the room, then the first person shot their gun, then the third person, then the second one, then the fourth person, and then you get everything that happens. And what you are effectively getting is a set of data points that tell you exactly what happened, not what is the system state. You are getting a history of everything that happened. It's like looking at a log file that says exactly every update, every insert, every delete, except that you're trying to make it business specific. So the terminology is not insert, update, delete, but it is very specific to the business scenario that you have. Exactly like in a log entry, right? So the other thing that is nice is that once you have this set of everything that happens in your system, that happened in your system, you can pass it through an observer. Pretty much like in a Symfony or Zen Framework event system, you can say, when this happens, then make this other thing happen. And this is another good thing, because I can now connect events of things that happen to next interactions. How do I react to it? So when a user registers, I want to send them an email. And when a user registers, I want to send them more emails to remember them and remind them of GDPR. So the system deals with what is happening in the system. This is very nice. It pretty much is the same as chaining together machines in a factory. You have the first machine. When the first machine has completed their piece, the piece goes to the next machine, and the next machine can start their work. And this is a very nice way to build stuff. Has anybody here got a Factorio addiction? Anybody play Factorio? Come on. So little. Okay. You should start with it, and don't tell others that I was the person telling you to play with it, because it's really, really highly addictive. I think it's pretty much like drugs. So after stuff happened, you need to react to it. And there is a second pattern, which I like a lot, which is CQRS, which is the separation of commands and queries. And when you combine it with some architectural patterns like a command bus, you can throw out commands at the system. You can tell the system what to do, and the system will be very resilient to stuff. It will be very resilient, as in, if something fails, if you're sending an email fails, if contacting GitHub fails, then I'm going to retry, and I'm going to add a log entry that tells you exactly why I failed, and I'm going to do this asynchronously, so I'm not waiting for a command to be executed, and so on and so forth. This is a very nice way to kind of like scale your system and have this pipe of things that happen coming out from a machine. Next machine, you got an input, which is tell the machine what to do. And this second machine is basically collecting all the information, and if it gets stuck, it doesn't just drop things, it keeps them in the entrance, and there they are. As soon as the machine is unstuck, it continues producing. That's the nice thing about this CQRS. So effectively, once you tell the system to do something, it will do it. It will finish their job. And then there's the planning. Planning and architecture, and planning with this kind of architecture in mind allows you to use a very nice mapping technique, and I would say exploration technique, which is called event storming. So what you do is you gather a set of people that are involved in the project. We're talking about a few software developers and 1 or 2 business people. And what you get is another external person that has nothing to do with the company. And this person is supposed to basically prevent these people from killing each other. Because, you know, software and business, they don't really like each other all the time. And then you start mapping out everything that can happen in the system. And you do it in a very visual way. So you have a wall, and you put stickies on it. And you say, this happens, and then this happens. And when this happens, then this other thing happens. And this is very nice, and compared to like having a specification, a PDF or a Word document with like 200 pages, or maybe a printed out one. I've had those. Printed out specification of what the software should do without discussion about whether it makes sense to do the things that the software is supposed to do. This is much better. This is giving you a visual representation of the system. Now, it gets a bit more formalized than that. It's not just about putting stickies. It can be formal to a certain degree, but that is kind of the idea. You now have a technique to find out what the system is going to do. And once you've done everything, you can map it one-to-one inside your code. The sticky notes become files in your system. They become classes. They become functions, one-to-one. Have you ever seen that? In a UML diagram, maybe, but a UML diagram is not something a business person understands. With a UML diagram or an entity relation diagram, you can't really do that. So you can map some interesting things, external systems. So things that are talking to your application, you can now put them on the wall. You know who is talking to you, what the risks are. You know that if Visa or MasterCard are going to lock you out, then you're no longer being able to perform payments. Therefore, this entire area of the application will not work. You know that you have to be able to be resilient to some kind of failure. So this gives you a good idea of what can go wrong without you having control over it. You can map, therefore, anything that can go wrong. A good example, again, is consistency. You want to sell televisions, and you have 10 televisions of, I don't know, a certain 50 inches screen type, and you sell them all, but to be honest, the warehouse may be on fire. You don't have those televisions. The real world is not your software. So you always have this inconsistency. And in warehouses specifically, what they do is every 6 months they do an inventory process to keep this consistency, to realign the data to what they actually have in the physical world. Because things get stolen, things get lost, things break, things get delivered incorrectly. So you don't have this kind of consistency in the real world. You should be able to deal with realigning the real world and the software at some point. And these are the uncontrollable events. And you can time sequence stuff. So you know what happens before, you know what happens after. And that helps you a lot because you know exactly what to expect in a production system. And you can then look at what is happening in the system and you realize, no, look, something is wrong because these two things are not in the right order. So why did this happen before that? And you don't need a developer to figure that out. You can give it to a business person, and they can tell you exactly what can happen in those scenarios. So you are basically dragging the business people into the realm of software development, and the people from the software development world, you're pushing them into the business world. And this is good. If you went to Robert's talk before, this is actually about bringing everyone together and pushing forward and not having these separate worlds where everyone talks their own language. Instead, we have one language where the software is actually data points in time which have a name, a label, a description that matches what the business expects. So, that was the good part. Now let's start with the ugly part. The ugly part, mostly because it's PHP, but we're talking about code. Code is always suboptimal. Once you wrote code, it's no longer the perfect idea that you had in mind. It's an implementation that has inherent bugs, because bugs are in the code, and because if you don't have bugs there, you have to remember that you have something like 2 million lines of code in the Linux kernel, and something will fail and hate you. So, events. Let's start with events. Right. So, an event is basically a class, an object, an immutable object. It's a data point. So we assign a label to it, right? And then it has some information in it, some fields, and some more fields of well-shaped information. It's not strings. It's not random integers. Please don't use just like random information. Please use types. Let the types help you in software development. And this is what an event is. So it's an object with just some state inside. There is nothing special about it. It's just new, this happened, okay? Then you need to raise these events. So these events come from somewhere, from a business interaction, from a decision. Once you took a decision, that decision becomes a point in time in history. So what you got is a concept called the aggregate root. The aggregate root is a class, an object that receives your interaction and moves the state of your application from one point to another, and internally keeps state and decisions and abstracts everything you can do with something. So, an aggregate root is effectively what we could call an entity in a typical system, but it is the object complement of our interaction. It is the thing that we ask to move the system forward. So, besides all the controllers, the SQL database, whatever you're using, this is where the important stuff happens, where we are moving the state of the application. Here I have a code review aggregate. This is an old version of what I wrote, and it's way too big, but I wanted to show you because this is a very primal version of what I wrote for my project. We are having this class, we're extending from some tool, from some library. Don't hate me for that, but it's making things a lot simpler. It has an identifier. So an aggregate can be identified. An aggregate can be a user, it can be a shopping cart, it can be an invoice, it can be a shipment. You have an ID, and the shipment can be canceled, can be delayed, can be anticipated, can be completed, stuff like that. It has more state. What is interesting about this other state is that this state is what we call transient, which means that it's not saved somewhere. This state is part of a reconstruction of history that we are going to perform every time we load this object from the database or from whatever storage we use. And it has a lot of this state. In this case, it has way too much state, and that is just because my first attempt at this was producing way too much state mutation inside a single object, which is just a single responsibility principle breakage that I had because I didn't have clear ideas of what I was doing. And what you do is you reconstitute this thing from an event list. So you build it from a set of events. So we create this instance, and then we loop over the events, and for every event, we are incrementing this internal version. So what this thing is effectively a stack of all its history. Everything that happened in here is going to be pushed more and more into this stack. And it can become quite huge. And every time we got an event, we replay it. And replaying it means moving the internal state forward. So replaying effectively takes an event and says, if the event is an instance of this, then we are going to set this internal state. So if the payment is completed, then we are going to set the flag completed. And we're going to set the clearing amount to a certain amount internally. And we do it. It's just ifs, and ifs. It's all the way down. It's horrible, but still, simple. From the outside, we don't see that. That's all internals. It's private stuff. We don't see that happening. From the outside, it looks like an entity. But what we can do is we can interact with it, and we can ask what happened in the last interaction. So we can ask it to give us information about what happened recently. So when we call a method on this aggregate, it is moving the state internally, producing new events, and once we're done with the interactions, we ask it to give us back what changed, and it will tell us what new history we created. And effectively, it's just an entity. So we can create it. Here is how you create it. So we have a start. This is a named constructor, so it's a static method. We start the code review with the reviewee, which is the person that is going to be paying for the review. That's the person that requested it. With a pull request and some access token, which is just necessary in order to get the code, to take some decisions. And then we create this object, and we record that something happened. So a pull request provided with some information. So we really just keep pushing to this stack, to this internal stack. Right. And internally, it's going to record the events, and every event is going to have a new version, a new incremental version. So this is how you change how you store things internally. So we're no longer storing fields inside our entity, but we have this huge stack. And when we load the object, we take this stack and we loop through it and replay all the state. So what it looks like is pretty much, it looks like an entity again from the outside. Internally, it's this stack, but it behaves like a state machine. Anybody remember this thing, this abomination? We've done it in school, I guess, most of us. But there's components, and it's getting more popular again. But this is what an aggregate is. So it's telling us this is how you start from, and every event is an arrow. So every time you have an event, you jump from one state to the next state. And what this thing does is it either allows you to jump from one state or the other, to the other, or it says no, and it throws an exception and says, sorry, you're not moving from here. This is not something I allow. So who calls this aggregate? This aggregate is your domain. So what you have is the core domain of your application, and outside, you have the application layer. The application layer is controllers. The application layer is your framework. The application layer is everything that is just pushing data around, translating from HTTP down to your domain. That is application layer. It's just glue. It doesn't do anything important. So it looks something like this. So first of all, you do get some of these objects by an identifier. So you can fetch it by identifier, exactly like with a database, like with the traditional database. You do something with the object that you fetched, right? You tell it to do something, and then you store it. You save it back. And storing back means take every new event that was produced and insert it into a table. Okay? So what we did generally is when we wrap this into a more structured application, is that we make the application layer isolated into what we call command handlers. So command handlers work really well when you use something like a command bus, and they are a very simple abstraction of an interaction, of how to execute an interaction, and they always look like following. They always look like following. It's just a class, no interface, nothing special, has some dependencies. Usually it's just the list of existing aggregates, that is a repository in this case. And then you are going to call it with a command here, which is an object that is abstracting the intent. And this command is just going to interact with the aggregate. In this case, we are creating a new one. And it's going to store it somewhere. So it always looks like this. Get some information that is usually abstracted inside a command, which is just a very structured way to have a request object. You are going to fetch or create an aggregate, and then you're going to store it after interacting with it. Everything that you got here now is a set of events. All this bunch of events gets thrown into what we call the event stream, which is a huge table. It's just a huge table where you can just go and stream over it. So you can actually attach something to it and say, you know what, from now on, every time you see an event of type X, please do this other thing. This is why it's called an event stream, so you can just loop over it. So you can listen and react to anything that happens in the application. So the other thing you can do is you can produce state. If you think about it, it's a bit tricky to decide how many users are registered in your application if you allow users to register to your application and cancel their account. Because now they have two types of event, user registered, user deleted. So you have to loop and add a user every time you have a user registered and remove a user every time you have a user cancel their account, right? So you can produce a list of everything you have in your system, but you have to loop through the past and produce what we call an aggregation, a reduction, or a fold. The other thing is the event store is an immutable data structure. So you can only append to it everything that happened in the past. You can rely on it. So this gives you some guarantees, because anything you have seen in the past has happened, and it doesn't change anymore. And therefore, if you took a decision, or if you produced some state from the past, you don't need to look back. The next time you are going to produce more state, you can continue from where you left last time, which means that we can cache any kind of interaction, any kind of copy of the event store that we did from the past. We just need to consider new entries to the database when we want to produce some more state. So effectively, we are doing a loop over the entire stream, over the entire event store. We are copying data around, right? And when we copy it around, we make something like a database, a relational database that contains our users and all the associations between friends and enemies and whatever you want to do in your system. And that structure that you produced is just a very, very long-lasting cache. Your relational database now became a cache, which is a bit scary. But it's a very different way of seeing applications in general. So these are called projectors. So you're taking data from a huge list and producing structured data that you can query, that is easy to work with, because you want to have tables, you want to have reports, you want to have a quick way to say if a user can log in or not. And effectively, they take events and produce more state. And generally, this happens in a database, but it doesn't need to be like that. It could be like an HTML page. So you take all the history and generate an HTML file. You generate a JSON file. You push data to Elasticsearch. Who's using Elasticsearch here? Right? Right? That's also terrible technology. No, just kidding. But effectively, you are already doing some of this, because you don't use Elasticsearch as a primary store, because it tends to fail. You have to kind of like restart it and give it a kick sometimes. But that's okay, because it's not supposed to store your information long term. You're supposed to have the information in a primary source of truth and copy it over when you need it, so that it is indexed in a more search-friendly way. And that's the same thing projectors do. Right. So this is what a projector looks like. Projector is, again, a class. Register new reviews in statuses table. This means when a new review comes in, we're going to create a record in the code review statuses table. So constructor receives a database connection of some sort, right? When we receive a pull request event, pull request was provided, then we are going to insert some records in the database. It's just copy-pasting data. There are more elegant and more efficient ways of doing this, because this is very slow, very inefficient. But this is the simplistic concept. We're just copying data around. And you can do actually this with SQL triggers. I'm not kidding. SQL triggers are a very good way to do this. And SQL triggers gained a very, very bad reputation because people use them to change data inline. So you're inserting data, and then you're selecting it, and the data changed. That's when an SQL trigger is terrible. You don't want that. But using trigger for copying data around is very valid and very efficient. And in Proof version 7, Proof is the go-to library, in my opinion, for event sourcing in PHP, for event sourcing and CQRS in general. Proof has now a system that makes this stuff less painful, because this is the most painful part of event sourcing. Hundreds of projectors to be written in order to make your data consumable by a front end or by a front-end team. Right. On the other side, we have process managers. Process manager is a fancy name for an event listener, which means that you have something that is like Pac-Man, that is munch, munch, munch on the event store, is just eating all the events that come in, and does something with that. So this is taking events and triggering new interactions. So it's a, if this, then that. When I am buying a product, then send the email with the confirmation of the purchase. That is what a process manager would do. So it takes events in and produces a command object that will be fed to the system again. And this is important because having this kind of abstraction allows you to queue operations. So you're not dogpiling operations in your system. Your system is more able to deal with operations as they come up and not in a synchronous way. Process manager is also, again, a class without interface. So this is an analyze an incoming pull request. So when a pull request is received, we want to analyze it. Dependencies, it has a command bus as a dependency. A command bus is a very simple abstraction. It's a function that doesn't return anything. It just receives a command. So we want to call this command bus whenever we have an event. So when a pull request is provided, we are going to fire a new command called analyze that pull request. Okay? When this happens, make this other thing happen. We're telling the system where to go next. The difference between a projector and a listener is very important. A projector can be run as many times as you want. So if you lose your MySQL or Postgres or whatever server, and you still have a copy of the event store, you can reconstruct the database from scratch by rerunning all the projectors. It will take some time, but this means that your database is a generated data structure that comes from this list of everything that happened. You can regenerate it as many times as you want. Instead, a process manager can only be fired once, because otherwise you're going to resend all emails and re-ask for payment for everyone, which could be fine. I mean, you're going to make a lot of money if somebody still pays that, but it's probably not a good idea to send invoices twice. So to recap that, let's make a larger picture of this. Somewhere in your front end, you have this command bus thing. This is going to be somewhere in your controller or something like that. This command bus receives a command, which is new, do the thing, do that thing, okay? I told you, do that thing. It's imperative, very important wording. It's into the imperative. We're telling the system what to do. We are coding this as an intent. Then somewhere else, we have a command handler. Could be on the same server, could be on a different machine. This command handler is a function that receives a command. It has all the history of our application, and it has some services that it wants to interact with. And inside this command, we get the thing. The thing is our aggregate, right? We fetch it from the history. We load it from the history with some identifier. Then we do something with it. We perform an operation that can also talk to the outside world. Okay? So we're doing a payment. We're performing a payment. We're performing a checkout. We're closing an account. We're hiring somebody. We're firing somebody, something like that. And then we're going to just store everything that is new from that thing. We're going to add those information to the event stream. And then somewhere else, completely unrelated system, could be a different machine, could be the same machine again, it's just an abstraction. We have a loop that goes over everything that happened in the stream and either fires new commands, so it's the process managers, the listeners, they fire new commands, or we produce new states, so we're copying around information. And this is pretty much the big picture. So, I like to add some Haskell to my slides lately. So effectively, event sourcing and CQRS can be abstracted to three functions. One function is executing a command. Executing a command receives a set of events, which is the history of our application, right? This is the first input parameter. It receives a command. It receives a reference to the world, because we need to be able to talk to the outside world, such as payment gateways, mailing systems, and so on and so forth. And it will give us a new set of events, which is the new history of our application. This kind of I/O thing is basically like it can fail, and we don't know how much time it will take to execute. This is what it is saying to us. And on the other side, we have a handle event, which is just from a set of events going to produce a set of commands, which basically means if this, then that. That's what it's doing. And we have a produce state, which takes some events and shovels them in some storages on S3, on our database, and so on and so forth. We can also write it in a completely different way. I'm looking at a different way to model the entire system, which is moving this I/O thing. So this I/O thing is in the execute command right now. So when you're asking the system to do something, the system can use the external world and talk to the external world to take decisions. There is a completely different way of doing this, which is to move this I/O inside handling events. So you have a long-running process that is there, like I told you, like this Pac-Man that is waiting for events and munching them. Like, how is it? Waka waka, does it do? I don't remember that. And this is effectively producing new history. So when it sees things happening, it sends mails, and it produces new event. I sent the mail. I did this. I did that. And instead, the commands become completely pure, so they never fail. It's a different way of seeing it. I still haven't decided on which one is better, but it allows you for some space in re-architecturing the entire thing. Right. What we can also do now is that we can graph the entire domain. We know that which command is going to cause which events, and which events are going to cause which commands, because we have a very rigid way of how to represent business interactions and their connections between each other. So we can do something like this. Now, I am terrible at graphs. You can see that. It's kind of like, yeah, don't do that. So if you draw it correctly, it looks pretty much decent. So you know that this interaction can fire this event, which can fire that command, which can fire these two events. And if there is a bug, and we say, look, we're stuck here, what do we do next? Or we don't know why we didn't move from here. Okay, there is a bug there. You can look at the logs of your system, you can look at the events of your application so far, and you can talk to a business person, and you say, like, tell me where the bad guy touched you. All right? Okay. And the business person is going to tell you exactly, oh, yes, we forgot to add this business invariant. We forgot to deal with that scenario. We forgot that this has to happen before. These are no longer software projects. These are business projects. We, as software people, are supposed to be hired to use our brains to make businesses more efficient. People are paying us for automation. Automation is what the value of our business is. We are removing stupid jobs. We're not removing jobs, we're just removing the stupid ones. Okay? Hopefully at some point we'll remove all jobs. We'll be also out of a job, but I hope it will not happen now because I'm having fun with this. So we can also do other silly stuff. We can create a commit graph of everything that happened in your application. So what you can do is you can create a branch every time you have a new command. Every time you have a command, you run a git branch. Every time you have an event, you do a git commit. And every time the operation succeeds, as in it doesn't crash, you don't have a critical failure, you do a git merge. So if you run this against your logs, this is just a very fancy projector. You can see everything that is happening in your application, and you can also see which operations are concurrent, which is very, very cool. So this allows you really to look at your application and figure out what our users are doing in parallel in different sides of the application. And it's pretty much like a very structured way of looking at your logs. Now the bad bits. This stuff is cool. You can do cool things with it. It's a lot of buzzwords. It's not as complicated as it sounds, but we're still talking about a paradigm shift, and we're not talking about simplifying things. We're just moving complexity around We're changing where the complexity in our system lives. So every interaction now is 6 things. Every time you have to write a feature, you start having 6 things to write. First of all, you have to write the aggregate, or the aggregate interaction. So we want to do this. Therefore, we should have some business logic encapsulated in an aggregate that moves us from A to B. This is what we are going to do. So we have some logic that moves us from A to B. To move you from A to B, you need to produce an event. Every time you do a jump in the state machine, you have an event. That is the event. That jump is the event. Then you have to have the command, which is abstracting what you want to do. So it's the name of your interaction. It explains what you want to do with your system. Like do the thing, complete the payment, send the goods, and so on. This is what a command would be. You have to write the command handler, which is glue code. If you have a solution for getting rid of all command handlers, please chat to me, talk to me. I want to get rid of them. They're honestly just glue code, not important stuff. And then you have to write projectors, because your interaction, yes, it's moving the state of your system, but you still need to see it in the UI. You need to be able to see the report table. You need to see the registered users. You need to have the PDF with the invoice, and so on and so forth. And this is what projectors do. And the schema changes with that, because you want to probably use a relational database. NoSQL databases don't really solve any problem there. And then you can have related listeners. So when this entire interaction is over, we have the next interaction. So this is a lot of stuff to write. We have a very well-structured way to write this. We don't have services anymore. We got rid of the service layer. There is no services and dependency injection for services anymore. But we have 6 things to write. There is an advantage, though. There is a clear wall between your current feature and the next feature, which is this guy, the listener, the process manager. This process manager is the wall between your interaction ending here and the next thing to be started as next feature. So when this happens, then we want this to happen. This is a new feature, which means that you can kind of have still advantages even though you have these many things to write. The other thing is, this is very hard to explain to developers who did not understand what I talked about today. This is okay. You can raise your hand if you have no idea what I'm talking about. Otherwise, I'm a genius. Right? Okay, I'm fairly sure somebody here did not understand. Okay? I'm going to start asking questions later. You don't ask questions to me, I ask them to you. But still, this is very different from what we're used. We're used to opening a PDO connection, running an SQL query, do an update, and that's it. Well, congratulations, you're losing data every time. Every time you do an update query, you are losing data. You're losing information that could be valuable to your business. So, we are used to this CRUD or craft stuff, and we're drugged by it. We're so used to it that we don't want to move away from it. So my suggestion is give it a try. It's not as complicated as it sounds. The other things that can happen here that are complicated is that now you have this command thing, and this command is a pipe. And if you make it asynchronous, you now have a message queue at the very center, at the very core of your application. And dealing with this asynchronicity in the very middle of your application is a problem. So every time you have asynchronicity, you have to deal with asynchronous thinking. Everything you do doesn't show up immediately on the UI. It may be happening 5 minutes later because your servers are catching up with work to be done. So you need to think about asynchronicity, about the fact that the UI is not always in sync with what you're seeing. It's not always that nice. So you are starting to get some advantages from a developer perspective, but some losses from a UX perspective. Developer experience versus user experience. So you need to kind of figure out, do we want to make things synchronous or asynchronous? Up to you. On the other side, you have a system that has already the abstraction for running a very simple update in the database, or uploading an image, or uploading a video. If you want to scale it, and by the way, I know this is not a really important thing here, because anyway, any of us is not building Facebook anymore, right? We're not building the next Facebook. And the European Union anyway said that Facebook is a monster, so it doesn't matter anyway. So you have a system that scales really well from a developer's perspective. It's easy to add features. It's about adding new commands and events. And it scales from a performance perspective because you have this synchronicity and asynchronicity where you need it. And you can also retry stuff. That's the most important part. You have something that can fail because the database goes offline, because the mailing gateway goes offline, because the payment gateway fails, and so on. And you can retry interactions. This is really, really helpful. And it helps you make the system more reliable in general. So what we did wrong when trying this is that we mixed a lot of stuff. We mixed domain and interaction. It's really easy to segregate the two between each other. You have a discussion with the people from business. If you're talking about concepts and they understand what you're talking about, then it's most probably domain. If you're talking with them and they don't understand what you're talking about, then it's most likely infrastructure. So business people don't care about MySQL. They don't care about Postgres. They don't know what a cache is. They kind of like hear about it, but they don't really know why it's there. They're more interested in why the shipment failed, why the shipment succeeded, why the shipment was delayed, why the payment got in or did not get in as we expected. This is the kind of business stuff that we want to have. So commands are part of the domain. This is what we want the application to do. This is what we're telling the application to do. So it's an imperative, and you can describe it to the business people, and they will understand it. Process managers are part of the domain. This if this, then that is something that you discuss as part of the feature requirements, as part of the deliverable that you talk with the business people. And stuff like copying data around, because we need this data in Elasticsearch. Nobody cares. I don't know what Elasticsearch is. Copying data around is not domain. So this is what we call infrastructure code. It's just supporting our application, but the business people don't care about it, and we shouldn't care that much about it either, because this is the stuff that changes all the time, because there's a new storage, because we need to upgrade the version of the library, of the database, or whatever we are using. So more stuff that we did wrong. And by the way, I'm reaching the end here. Events being too fat. Too fat as in, not me, but too fat as in you have too many fields in them. And the reason is really simple. You have this structure, which you call the event stream, which is just containing everything, and you cannot change it. It's immutable. Once you inserted something, you cannot change it. So if you have a very complex event, such as, I don't know, what is it? Record preferences. If you have something like a record preferences event, that event has 20 fields, it is very likely that somebody wants to remove or add the field. It is very likely that somebody will say, you know what, that's personal data, we need to scrub it. We need to get rid of it. And this becomes problematic. The more fields you have, the more likely it is that you will have to change it. And changing events is a non-trivial problem. There's like a 70, 80 pages book by Greg Young about it, just to give you an idea of how complex just that one problem is. Once you have written an event to the storage, it's there. You are not going to change it. If you change it, you're going to have a sea of trouble. It's going to be a lot of problems. So don't do that. So make many tiny events. User changed username. User changed address. User provides, I don't know, phone address. Stuff like that. This is the kind of stuff you can make atomic. And remember to not save personal information because GDPR, blah, blah, blah. Okay? So, all right, I'm going to skip over a bunch of this stuff. Right. So, what we also did is executing logic outside the aggregate. So we had a lot of problems because we moved logic outside in peripheral parts of the application that get easily replaced. If you have something that is a support system, like a connection to the database, a connection to RabbitMQ, or something like that, you don't want to push business logic in those areas of the application. Try to keep everything concentrated in the area where the aggregate happens. The aggregate also should only be called once per interaction, because every interaction can also fail. And if your interaction fails and you have some events pending inside the aggregate, you're going to lose those events. Those are decisions that you took. Once you took a decision, it should be saved. You don't want to lose any of the decisions you have in your history, in your application history. So it's there. It's supposed to guarantee consistency of your system, not allowing you to jump from A to locations that are not supposed to be reached. And in general, denies invalid actions. So it just throws exceptions and performs some interaction. You never ask it for data. It's a black box. You tell it what to do. It's like the car. Okay? You don't go in the engine and change stuff. You just use inside the wheel, the steering wheel, and the gear, and the accelerator pedal, and that's it. That's your interface. Okay? You're telling the car what to do. The car maybe tells you the speed, but not more than that. Okay? Try to keep this read interaction minimal. Right. Sometimes it's also interesting to skip this business logic. So you can have a support system where you can say, people phone you because they don't have a credit card and say, I did a payment by hand, and here's the confirmation number. And what you have on the other side is you have a support team that answers the phone call, and they're like a super admin, and they can produce events by hand, and they can say, this was paid, so we can unstuck the system. And this is quite useful in general. So, a few suggestions here to close off. This is a lot of stuff to learn. It's a lot of new, interesting stuff. You should give it a try, in my opinion. But when you go and try it, don't use Kafka. Where is Luis? Luis, don't use Kafka. You know the libraries for PHP for Kafka are shit. Yeah, right? Don't use those. So use boring technology. Boring technology, you're used to it, you are familiar with it. If it fails, you know how it fails. So please keep it on boring technology as much as possible while trying this new fancy stuff. Don't mix everything together because you're going to get burned. And you're going to hate it, and then you're going to be like, oh, CQRS and event sourcing sucks. Right? No, you just probably went a bit too far. So what we did is we used Postgres. We used only Postgres, even as a message queue. I rely on that database a lot. Stable technology. It's older than me. Postgres is older than me, I think, by something like 5 years or something like that. So we still rely on database transactions. We still rely on some indexes, and it has awesome JSON support and whatever. Use stable, old technology. So don't focus on the performance bit of the application. This architecture kind of solves the performance problem for you. So you don't need to worry about that. Instead, let the architecture solve the problems, the hard problems for you. And yeah, that's kind of like what the command was. So everything quite fast. And in general, right, I'm going to skip here, but in general, the most important thing is you need to have a business domain that matches CQRS and event sourcing. So it's a process-oriented system. One thing connected to the next one, connected to the next one, connected to the next one, and they act in a chain. If you have that, then event sourcing can be a good solution for you. Otherwise, it's a world of pain. I can tell you it's like a lot of work, and it's not worth doing. So please give it a try. Make sure you have the scenario for using it, like I explained at the very beginning. And if you have any feedback, please let me know, and thank you very much. Do we have time for questions?
Any questions for Marco? No?
No? Everything was perfect. I'm a genius, right? Yeah?
Okay.
All right, cool.
Thank you, Marco.
Beer, right? By the way, I'm not a genius. Okay?
I believe this is the only opportunity for me to be on the stage with the beer in my hand, which must mean that we are finished for today. So, today we had a chance to see Erin, Dan and Alexander, Tomasz, Luis, Michael, Miro, and Marco. So, this concludes our first day, and I hope to see you all here smiling tomorrow morning. And now, go to the middle track, have some beer, and listen to some good music. Thank you for paying attention today. Thank you very much.